Everybody hear me okay? All right, good deal. So just level set what the session is going to be about today. So, we talk about the traditional supply chain pipeline, but there's really a data supply chain pipeline now. This is not an analytics discussion or a BI discussion. This is about an enablement discussion. And so I'm going to talk a little bit about enabling the data science community, enabling the business intelligence community, enabling leadership by building what's required to build a data supply chain pipeline. Before I get into that, a little bit about myself. So I've been in the DoD for 11-ish years now. I came up in the RTD&E community, missile research, and so you can imagine over those years that when you fire a missile, it produces a lot of data. How do you get that data back? How do you prepare the data? How do you organize the data so that the folks, actually the data scientists and your engineers, can actually do the work to do analysis? So a lot of this has been developed over the years, working with different customers in order to kind of come to what I'm going to present today. And again, this is an evolving thing, right? This is not something, it's not a static entity. And so, keep that in mind that this is a framework, this is a methodology, but just like with everything in AWS, it's building blocks. You can take this building blocks and tailor it to your own needs. So just kind of start out, I'm not a big fan of Wikipedia, but I will say that it's design, planning, execution, and control of your supply chain activities with the objective of creating value, right? What is the value? We'll talk about that. Building a competitive infrastructure. In the world of the Department of Defense, you're talking about building an infrastructure that's able to meet the needs of the mission execution. Leveraging worldwide logistics. Anybody that's in the DoD knows that it's a worldwide logistics organization. Talking about Transcom, LOGSA in the Army, that's what they do. And how do you measure performance, right? So the use case, and if this looks familiar, it should look familiar to most DoD customers, is an organization has tens, hundreds, thousands of disparate, heterogeneous systems, applications, devices across multiple organizational domains, right? There's not one personnel system that has all personnel data. There's not one logistics system. So just as an example, Army Logistics has 96 systems of record. That's a lot of stuff for just that one part of a specific piece of the domain. So how do you ingest all that? How do you consume all that information? What do you do with it? Each organizational domain has multiple systems of record that has data about similar entities. I might have information about an MRAP in one system. I might have information about an MRAP in another system. And they might have conflicting information about that particular vehicle. Real use cases that I've seen. Leaders need to be able to ask single domain and multi-domain questions and receive a single accurate answer. For example, what is my force readiness if a conflict arises in pick your region? What does force readiness entail? Personnel, logistics, training, all of the above. So you think about the 1 through the 8 or the 9. How do I integrate all of that information from the sources to the leader to be able to enable them to make decisions? This is a multi-domain question. So, the importance of data. It's an organizational asset. It's not an IT function. One of the biggest trends you're seeing in industry today is the advent of the Chief Data Office, separate from the Chief Information Officer and separate from the Chief Technology Officer. And it's being embedded into the business. So the CDOs are going to have a lot of liaisons with other functional domain parts of the business. Extremely important, because this is not an IT function. This is an extremely critical organizational asset. Data, context, relationships, information. That's what you're getting to. I'm taking data, I'm putting some context around the data, I'm building relationships among the data, and I'm providing information. Important to note is relationships does not mean correlation. Correlation is an analytics function. Relationships is a business function. Two very different things. Information provides strategical, tactical, operational advantages by enabling execution of the mission better than your adversary. And that's really what you're getting to when you talk about in the military offset factors. How do we offset the fact that a particular country has 1 million soldiers? We offset that through other things that are going to be force multipliers. Data is a huge force multiplier. It allows you to be where you need to be before you know you need to be there. Importance of data for machine learning, deep learning. This is the new, and everybody wants to talk about machine learning and deep learning and how can I enable AI. the end of the day, AI depends on the data. If you talk to any of the data scientists, Dr. Wood that runs Amazon's machine learning, recognition, all of that part of the business, they will all tell you, without good quality data, the best modeling techniques in the world will not give you accurate results. It's a big problem today across organizations because everybody wants to do the machine learning piece, but how do you get there is the question I'm trying to answer. So the mission statement is what I'm trying to do is I'm trying to democratize data by creating an accurate and consistent view of the organization with the purpose of providing actionable, strategic, tactical, and operational insights in order to enable execution excellence. Now, that's kind of a lot of stuff, but that's really what we're trying to do. We're not in the world of autonomous AI systems yet and things like that. There's still a human in the loop, but what a commander or at the strategic, the tactical field levels making decisions, they need to have the better data they have, the better decisions, the more actionable decisions that they're going to be able to make. So I always talk about operating models, and the book that this is out of is actually in this slide I'll show in a minute, but this is, I think, hugely important because it simplifies the problem, is that your current state today, you have a diversified operating model. You have data all over the place. It's not really integrated. You could make the argument that there are some systems that grab it from here or create a data warehouse over here or do something, but the reality is it's not really integrated. And by the way, this data model is not prescriptive. It's not a right or wrong answer. Your business may want to operate in a replicated business model, operating model, unified. Unified would be an instance where we had one personnel system, one logistics system. That's just not the reality in defense today, and quite frankly, a lot of other large commercial entities as well. So what you're moving towards is more of a coordinated operating, where my business still functions as my business, so my logistics still functions the same way, my personnel functions the same way, planning functions the same way, but I have a 360-degree view of all the things going on within those organizations by coordinating the data. So this is out of a book called Enterprise Architecture Strategy. If anybody's interested, it's actually a great primer on using enterprise architecture into solutions architecture from a business context. So everybody's seen the 5 V's of data, but I think it's important to kind of review, what are we talking about? We're talking about building the pipeline. What are the requirements of the pipeline? I've got to have the volume of data, right? I mean, we're into petabytes of data now. I mean, we're into petabytes on our way to exabytes of data in a lot of this. Current state, some of the projects I'm working on are petabytes of data. You got to have the system to be able to ingest that data. You got to be able to handle all of that data. How can I do that at scale at a cost that doesn't break my budget? The velocity of data. How fast am I ingesting data? Time-based or event-driven, right? Real time is time-based. Event-driven, something happens, I get some information. Gigabytes a second is probably what you're going to see. I've seen some examples where you may start getting into terabytes per second. There's some pretty heavy hitters out there, but most of the time, that's kind of the field you're in. The uniqueness in the Defense Department is that you don't know what your connectivity is going to be. It varies from base to base in a CONUS region. OCONUS, it varies. I could be somewhere in Afghanistan or somewhere in Germany. You don't know. You have no idea. So you have to build your system to be able to accommodate different levels of connectivity, different ways that users are going to send data. You have the variety of data, structured data, semi-structured, and unstructured. So kind of start at the end. Structured, what is structured data? Structured data is going to be your traditional RDBMS stuff, things that are, a social security number that have defined structures to them. Unstructured is going to be your imagery, audio, text, computer vision analysis, things like that. A lot of stuff kind of falls in the semi-structured realm, though, and that's really kind of the catch-all for everything else. And so you've got to be able to handle all of those. So you're talking traditional RDBMSs, NoSQL stores, flat file repositories, object stores. You've got to be able to handle all of that information that you're going to be consuming. The veracity of the data. This goes to supply chain security. So there's a lot of talk in, specifically in defense. I came from work at Space and Missile Defense Command where there was a lot of interest in supply chain security. Am I getting the parts and pieces to add to my system that are accurate, that are authentic, that are consistent, reliable? There's a whole bunch of that. That's the veracity of the data. And then the value of the data is the decision making, strategic, tactical, and operational. That's the end game. That's why it's a business asset. It's an organizational asset. It's not a technical asset. So what is the data supply chain pipeline? Just like any other data supply chain, I've got suppliers of data. I mentioned they could be systems of record. They could be IoT devices. They could be some, the warfighter out in the field collecting information for some mission. Doesn't matter. I don't really care who the suppliers are. I just know that I want to get the data. I've got to collect and process the data. I've got to figure a way to ingest the data, and I'll talk about this in detail and how to do some other things with the data. I've got to process it. I don't mean process in the terms of analysis. I mean processing of getting to a point where an end user, a data scientist, a business intelligence user, somebody can actually use the data, right? Make it usable across domains. Again, if I had one system of record for personnel, pretty easy to do. Just within the Army itself, I think there's 1,500, 1,900 sources. It's a lot of stuff, and that's just structured data. So you're talking, again, it's a scale problem. Organizing and cataloging the data. How do I organize it so I can build a catalog so users know what they have, what I have access to? If I don't know what I have access to and I have questions to ask, how do I know where to go to ask that question? So as you move along this, what you're doing is obfuscating that in the data supply chain pipeline for the end user so that they're able to spend their time in a value-added position other than trying to do all this for themselves. Search and prepare. Again, I'm an end user. I want to go look at a catalog, search through that catalog, and then pull that data out and prepare it for my use. I might not want to use an RDBMS. I might want to create a Parquet file, drop it in a Hadoop cluster, and do some kind of analytics on it. I may be, SageMaker. I want to use something with SageMaker. I may want to just use Jupyter notebooks on an EC2 instance and do some analysis against it. That's the preparation of the data to get it in that spot where I can do it. From my perspective, that's the power of the pipeline is I don't really care. I just know that I can present it to that end user to be able to do how they want, when they want, and in what format they want it. Explore and discover the data. Now this gets into the analytics piece, and now you're starting to get towards the tail end of the pipeline. I want to know, what do I have? It's the unknown knowns. Now, there was a comment several years ago about that. But in strategic decision making, that's actually pretty relevant. You have all this data, but you don't know what you have locked up in all of that data. And that's the power of all this is to be able, hey, we have all this stuff, and we've got to do all this searching to go through it. And find, hey, what do we actually know about our organization? Or what do we not know about our organization on the other side of that? And then analyze and report. So this is like I said, your data science community, your business intelligence community. These are the people that are building the quad charts for the commanders, building the daily briefs, doing, intelligence analysis on the data. And then your consumers. Your consumers are going to be your leadership. Anybody that's consuming information. I'm not consuming data anymore. I've got to get information out of this. So when I'm looking at this, one of the things that to be successful to go out and get this information, because part of the challenge, right, you've got 1,500 data sources, let's say, and I've got to be able to go out and get those data sources. I've got to have some kind of design principles, architecture design principles. Probably the most important one is minimal disruption, especially in the DoD. When you think about it in the context of, if I went out to a mission application owner in some other place and I said, hey, I want you to make these changes to your system in order so I can get your data. You end up with 1,500 UFers at the end of the day. That's a big challenge, unless how do I do that? So you want to minimize the disruption of getting the data from the end user. So as a principle, I want to eliminate disruption to data-producing systems, application, device. I want to make it easy for them to send me stuff, give me data. I'm going to be able to do it on their terms. There's some things that are involved in that as far as negotiating and things like that, but I want to make it as easy as possible for them. And I've got some customer examples of where that's been successful. Configure versus customize. This is the famous, do you build or buy scenario. With AWS, and I'll show this in some of the architectures, you can pretty much configure or put these components together at least 80% of it. And that's kind of the threshold I like to use for a build versus buy scenario. Decoupling. The pipeline stages are independent of one another. They're not dependent. That's important. Build it and make them come. Customers should be able to access the data where it lives regardless of their own location. So if I pull all this data into my data supply chain pipeline, I don't want to then have to pass it back out to everybody else. I want to make them come in, hook into my pipeline, be able to do their work in my pipeline, and then they can go and take the results out and go do something. But the problem is you get into is with the veracity of the data, is moving all this data around, then you lose control of the accuracy, the authenticity and all that of the data. And so, plus there's just the cost of doing it, right? Do I want to start moving terabytes, petabytes of data around? You get into some of the situations you have today where you have silos of random warehouses all over the place. And so, in AWS, you could, create a virtual private cloud with your data supply chain pipeline and allow people to come in and hook into that as they need to. You have a security context around it and such, but you don't have to move the data around at that point anymore. So what does the architecture look like? So this is taken from an Air Force example. So the Air Force has the A1 through the A9. Again, those are providers of data, right? You think about the curation cycle. I'm going to collect it, right? I'm going to ingest the data. How do I go out and get the data, right? I want to clean the data. I want to apply some quality rules to the data to make sure that, again, the veracity is correct. I want to stage the data. I've got to put it in a place where I can move it through the pipeline. The processing of the data has to do more with applying organizational policy and business rules. It's not processing it in terms of doing analytics and things like that. That's where the meat of this is. That's not a technical challenge. That's a business challenge. How do you define those rules? How do you engage with the business and do that? And we'll talk about that in a minute. Parsing, profiling. I want to standardize it. I want to associate the entities with other entities that I didn't realize before that had some type of business relationship. I want to organize and catalog the data. Again, integrate, aggregate, partition the data. I want to put it in a spot where somebody can come in and look through my data catalog and say, how do I answer this question? Here's all the data the resources I have to go answer that question. Then the search and prepare. I'm selecting the data. I'm doing the data munging if for some of the data scientists that are in the room. How do I put a categorical attribute into a binary? I want to enrich the data. I want to add stuff to the data that provides value. And that curation cycle is cyclical. So this is not a one-way street, and it never ends. As you get more data and collect more data, you'll get better and better at it, and it'll be an ongoing process. Think about it as it's an organizational capability. Explore and discover the data. So that's when I start getting into some of my analysis of the data. Some like correlations. Things that affect other things, right? I have these things, and they have some kind of correlated effect on this other thing. Trending, outliers, just basic statistical analysis to help me understand what I have. You have the analyze and report, and I kind of break these up into two different areas. I have what I call wholesale users, which are, I call them people that know the math, right? The data scientists, data engineers, those type of folks. And that's where you're going to get more into your, true analytics, machine learning, the data science community, if you will. But a lot of it you have is your retail users that are going to be your BI community that are going to be doing reporting, using tools. There's thousands of BI tools out there. That's actually going to be your bigger community at the moment. They're going to be creating your leadership briefs, your quad charts, your daily support, your performance dashboards, maybe even mobile. Machine learning is generally going to be the output of your wholesale community. And then the delivery of it, right? I'm delivering information products to the consumers. So from an Amazon perspective, again, this is a reference architecture. This is one way to address it. I've got other reference architectures for other customers that I've injected other AWS services into. So I want to acquire the data, right? I can send it via an HTTPS endpoint to S3. I could actually send it to SNS if I wanted to do it more frequently, if I wanted to use more of a pub-sub model, right? I could publish my data. I could go have my system application or devices publish data to this endpoint. It's completely discoupled. There's no dependency between that. Traditionally, if you own a system, you might plug an ETL tool into that, right? You might go plug some ETL product into that and extract the data in real time. But the reality is, if you had 1,500 sources, can you really manage 1,500 ETL processes? Oh, and by the way, you've got to negotiate that with the application, integrator, vendor that owns that application. There's a lot of stuff that goes into that. It's very challenging if you don't have direct influence, and I'll talk about that here in a minute as well. But again, I can send all that to S3, right? I don't have to worry about storage at that point. I don't have to worry about buying hardware or what if somebody sends me a 10 terabyte, well, the limit. So if somebody sends me like 10 terabytes of data, what is that? No, I don't at that point. I can consume as much data as I want to. So just for structured data, I can put that into into an RDS service, right? I don't have to go out and install a database and do all these things. And this is really for structured data at the moment is what I'm really referencing. It becomes more of an operational data store. So I want to go out and put all this in one place. And I'll talk about MVP and IOC in a minute, but that's really the collection point of all that information. There are other ways to do this, but this is just a pretty simple pattern that I've implemented and I'm working with customers and implementing today. So the meat of it is in the transformation and the processing. I want to apply some business policy rules to it. And that's really the challenge, right? I've got, I could use Glue as an ETL. I might use some other tool. I could maybe even Athena if I wanted to. There's lots of things that you can do, but the processing is more about the business and the organization itself. It's not a technical challenge so much as it's an organizational challenge. The interesting thing is when you get to organizing and cataloging the data. So if you think about it in data warehousing terms, it's kind of an old school term, it's been used around a long time, but it really has value. And there's two different kind of schools of thought in warehousing. There's kind of the Inman versus Kimball, for any of you data modelers in the room. And it's do I keep my data in a normalized fashion that comes from my system and then denormalize it and put it in dimensional models and things like that, or do I do that straight from the system of record? In this particular use case, remember, you're getting a lot of information from a lot of systems of record that have things about the same entity to them. And so it would be very challenging, and I've seen this in practice, to try to just denormalize that in one shot. And so what I try to do with customers is build those business relationships in more of a traditional normalized model. Think of like a data vaulting model or something like that. And then take all that and be able to denormalize it into a Redshift, an EMR. So if you're familiar with Redshift, it's our MPP columnar data store. It scales to petabytes. It's a true MPP. You can do really interesting analysis with it. EMR is our Hadoop managed cluster or managed service. And then Neptune, if you're not familiar with it, is our graph database service that was just released. So interesting about that's a lot of analysis is moving towards, if you're familiar with like GraphX and Hadoop, a lot of analysis now is moving towards graphs, building relationships, among entities. So all that can be piped in, extracting data out of my warehouse in the sets based on, the integrated data model, based on the subject or interest that I want to pursue. I could also roll that into S3 if I wanted to, right? The interesting thing is everything below the warehouse could be ephemeral. I don't need to stand it up. I might have the commander may say, hey, I need you to answer this question. I could spin up something to answer the question, spin it back down, my data stays there, but the underlying analytics platform can come and go as I need it. So I don't have to stand up, spend a lot of time standing up hardware. I can templatize all that stuff. I can stand it up in parallel if I wanted to, which is really interesting, right? I could do this I could stand up multiple Redshift clusters, and I could look at a question, the same set of data, several different ways. So there's really a lot of power in that once you get into this environment. Search and prepare, you'll see a lot of the same services that can be used in this. Again, for explore and discover, report and analyze. And again, I'm just giving it back out through portals and APIs. Anybody that wants to come, assuming there's the correct security context around it, can come get that data. But if the one thing you'll notice in this whole thing, it's almost 99% serverless. So I've actually implemented these that I'm not managing an OS. I'm not doing any of that stuff anymore. I'm building this whole thing, as a service, if you want to talk about it like that, without having to install an OS anymore. I'm not having to STIG it. I'm not doing IAVA compliance. I'm not having to do all that stuff because all these services have, for the DoD specifically, the provisional ATOs that are already in place for those services. It streamlines the RMF process. Also, I can do it across all classifications of data. I can do it in GovCloud, Impact Level 4, Impact Level 5 for unclassed data. I can do it in the secret region now, Impact Level 6 data. And I can do it in the TSSCI region, which are all accredited. So I can build this 3 different times off of a template, and I can use the same process for the pipeline. So let's just say I want to consume a bunch of unclassified data, and I want to do some analysis against it. The data in and of itself, consuming it, does not change the classification of the data. What changes the classification is the analysis and the relationships of the data. And so you might derive some piece of information out of that data, or that set of data that is classified, or maybe a piece of intelligence information. It may belong to a special access program or something like that. And we can move that throughout think about the data supply chain, not just within a region, within a GovCloud or within Secret, but across all of them. So I can pipe that data all the way through. And so I might have some classified data that I want to marry with some unclassified data in the Secret region. So it gets really, really interesting when you get in some of the use cases that I've seen out there that customers are, with real customers looking at, wow, I've been able to unlock stuff that I've never been able to do before. So how do you get started, right? In startup, prior to all of the DoD world, I was actually in the startup community for a number of years. And so how do I build a minimal viable product that has value without breaking the bank in a short order of time? DoD, what is my initial operating capability going to be? So collection, right? How do I collect it? There's no tool for collecting data from disparate systems. There's no single tool that I can go out and press a button and it's going to go to all these systems and just yank all this data in. It just doesn't exist. So what I want to do is focus on cultivating the organizational competencies and the processes for engaging with suppliers. How do I do that? It's not a technical challenge. Build Tiger teams to understand the organizational domains. I don't want to send 50 folks out to a single entity and do this. I want to build folks, and I've actually done this in the real world, to go out and engage with mission application owners on how do I get their data. Because there's not going to be one way that they can send it, right? You're going to have, somebody that is capturing changes that can provide those. You might have somebody that their system is not capturing changes, so they just might sending you database dumps every night, and you have to do the compare. There's a million different ways that you might be getting data out there, and you've got to be able to go out and negotiate that with the mission owners and able to do that in order to do that. Develop templates for MOUs and ICDs, so interface control documents. So I don't mean write a dissertation. I mean simple documents that say, mission owner, what can you send me? How can you send me data? Are you able to capture changes? When can you send it to me? I can send it to you on a daily basis, on a per second basis. Great. And really what it's doing is just defining that relationship with the data supplier is what you're doing with that. You want to keep it simple. If change management, if something changes in your data model and I'm getting a different piece of data, how do I let you know that so you can adjust your ingestion model accordingly? Very easy to build. I've seen folks get out of hand with it where they've built like 10 pages of it. Generally, I try to keep those to one single page where it's easy to understand, easy to comprehend, and it makes, again, it's minimal disruption on the data supplier. Interface control documents. What am I getting? Right? Just at a minimum, just tell me what the data element is, and if you have a definition, great. If you're lucky, you'll get a data model. Generally, you're not going to get that. But again, an ICD is, as part of my memorandum of understanding, I'm going to get this ICD, and if something changes, I'll just let you know. Not a big deal, right? It's pretty easy to do, but again, keep it simple. You want to make it painless on the data owner. Use AWS services to build and enable the right technology for the solution. It's not, my comments on my reference architectures, that's one approach to it. You might want to use Kinesis to stream data in if you're able to do that. You might want to use queuing services. Somebody just wants to queue the data. I mentioned the pub-sub model. It's not one way to do it. But what you can do with AWS is build that framework out to be able to do all that consumption in pretty short order. So the result is going to be a small set of common collection and processing patterns that can be standardized, automated, and scaled to hundreds of thousands of suppliers in AWS. We don't have really limits on the scale. I mean, there may be some theoretical limits, physics, you can only travel at the speed of light type thing. But, the biggest thing is automated and scaled, right? In practice, I've seen, 7 or 8 common patterns that tend to emerge out of that. The first time you go through this, it'll be a little painful. The second time, it'll get a little bit easier. But after you go through the iterations of this a few times, it becomes an organizational capability that you're able to go out and do this. Then you're able to automate it. You're able to scale it. You're able to do all these things very easily that you're not necessarily going to be able to do on premise. So S3 is just an easy example, right? I don't really do anything with S3. I just set it up. I get my endpoint. I send data to it. It just grows. I don't have to manage the storage volume. I don't have to manage anything behind the scenes. Simple notification service, if you're familiar with publish and subscribe models. I don't really care how many people are publishing to me. It's going to scale to meet that need. So there's a lot of different ways. But again, it's about going out to the mission owners and engaging with them on how the best way to get the data. So a couple of patterns. This is a little more technical. You've got your traditional ETL processing, change data capture, push-pull, transaction logs, slowly changing dimensions. So, in that context, I mentioned earlier, you don't know how somebody can send the data to you, right? I could be sending you a SQL Server backup. I might be sending you an Oracle data pump export. I might be sending you MySQL bin logs. Everyone's going to be different. Somebody might be able to send you a JSON document with changes. Great, that's awesome. But the expectation is you don't know what you're going to get. You can't force that onto them. That's never really worked at scale in my experience. You could also, a traditional pub-sub model, which is actually some of the ones if anybody's interested, we can talk offline about that, about topic-based and content-based publish and subscribe from various, and that's more in the context of, I want to send on a more frequent basis or in disconnected compute. So I might have something in an austere environment somewhere where I may have spotty connections and things like that. So circles of concern is something I kind of came up with to really drive home to think about how you're going to collect the data. And so you've got 3 of them, and I've got systems that I control, right, which are owned and directly managed by the collecting organization. I can go to them and I can put in an ETL, I can extract the data, I can do all those things because I own the budget, I own the system, I own the policy, or whatever it is. Those are few and far between. That's just not a realistic way to approach it because there's not that many of them out there. You have kind of a second tier where you may have influence, over a particular system. So you might be a user of a financial application that has some influence over the way, but again, you don't own the system. So now I don't have as much influence as how I get the data. Most folks fall into areas of interest where I have an interest in getting the data, collect and organize, has a process for the data, but does not have control or influence over the application. So it becomes a negotiation with the data owner on how do I get that data. Why is it important? Because that determines how the data is going to be collected. Very, very important when you're going through this. So a little bit about the processing. So everybody's sort of business rules, but I think you've got to distinguish between hard rules and soft rules, or what I call quality rules and policy rules, right? Hard rules are going to be things that are quality, that are independent of the business, right? Typically, the hard rules are going to be very easy to implement. So you got things like a social security number must have 9 digits. And this goes back to the veracity of the data, the accuracy of the data, the validity of the data, and all that stuff. You want to make sure before you expose that data back out that you have this, these quality implemented into your data sets. Social Security is always going to have 9 numbers. That has nothing to do with the business unless you're the Office of Social Security. That's just the fact. An address must be a valid per the USPS. Nothing to do with the business per se, but it's just a valid address. Those are hard quality rules. Quality rules are fairly easy to implement. That's been around a long time. There's not a lot of ambiguity in those. The challenge is in the policy rules that add context or alter business value or meaning. This is where a lot of your non-technical time is going to be spent. So, a social security number and date of birth must be a unique combination. That's a business rule. It's not a quality rule. This one is actually taken from the VA. A mailing address for a prescription drugs cannot be a P.O. box. If I'm in the VA, I can have many mailing addresses. I might live in Tennessee for 6 months out of the year. I might live in Florida 6 months out of the year. Those are real use cases. I might get mail to my physical address. I might get mail to a P.O. box because I'm moving. But if I want to get my prescription drugs filled and sent to me, that can't be a P.O. box. So those are business rules that you have to account for. I'm pretty familiar with the Army logistics piece of it. There's a lot of that in Army logistics that make up specific parts of the domain. So you have to account for all of that. It's not an easy fix. It's something that it's an acquired skill that you develop over time. So a little bit about the technical architecture, and I mentioned some of the ways to do it. So for those of you who aren't familiar with the DoD, you have the IAP, which is the Internet Access Point, and you have the CAP, which is the Cloud Access Point. So the DoD kind of used generically as a bunch of defense networks, and I'm specifically on the unclassed side right now. So I can send data, let's say, through the IP or the CAP. I publish because SNS and S3 both have HTTPS endpoints to either one of those endpoints. If my data, for instance, if I'm sending changes more frequently and they're less than 256K, which is the limit on an SNS message, I might want to publish, just publish the data to SNS with the message. If I'm doing it on a daily basis where I'm sending 5 gigabytes, I might want to publish to S3 and then publish the message itself, just say, hey, I published this to S3 on SNS. Not one way of doing it. This is just a pattern. In my VPCs, I'm going to have, I could have my data lake. Again, a lot of this is serverless. I'm using VPC more as a reference. If somebody, this particular customer I was working with kind of wanted to roll their own tools, and so there was some EC2 instances and tooling. But again, it's very flexible. Data lake, right, what we talked about. I include operational data store in a data lake because I'm really just bringing the raw data in with some quality rules applied. Data processing, we talked about that, quality or business rules. The warehousing, the organization of it, and then building those data marts off of that warehouse. The data marts is the piece I spoke about that was ephemeral. I can build as many data marts as I want to, in parallel if I want to. I can build them very easily. I don't have to procure equipment. I can just spin up a Redshift cluster, an EMR cluster, and pull out information in. On the other side of that is where you're going to kind of have your analytics as a service model. So you think about when I try to build it and make them come, right? Anybody can come in. I'm a user from some organization in defense, in the Navy, let's say, and I want to come in and I want access to this data. I can stand up my own virtual private cloud. I can peer into this data supply chain pipeline. All the security context is in place, of course. And I can do my analytics without having to pass that data around anymore. I can stand up whatever analytic tools I want to stand up. I could use AWS native analytic tools. I could use my own, my own implement of EMR. I could use my own instances of Redshift. I might want to use Tableau, let's say. The use case, I could launch Tableau in there if I'm a BI user. The power of it is I'm not moving the data around all over the place anymore, and everybody has access to the same set of data. And so when they're answering questions, it's going to give them the same framework, the same base in which to answer those questions. So from breaking that down a little bit more, what does that feasibly look like, right? Publishing, I've got my S3 buckets. I'm staging it in RDS, right? And when I talk about staging it in RDS, what I really mean is I might have an application that has an Oracle database. I might have an application that has a MySQL, a SQL server, whatever. You're not going to change that. And so if they're sending it to me in a proprietary format, for instance, like an Oracle data pump dump or a SQL server backup, I've got to be able to restore that and stage that environment so I can pull it out of that particular RDBMS to pull forward through my system. And that's really what I'm talking about staging. If somebody's sending me a flat file or just a JSON document or something like that, I don't really need to stage it in a particular vendor format. But from experience, that's a lot of what I get in is we're only able to send you a backup or we're only able to send you this particular proprietary format. And so you've got to be able to deal with that. From there, I can pull it through an extract and load process into my operational data store. So what I'm doing at that point is I'm taking all of that different vendor proprietary stuff and I'm pulling it into like an Aurora Postgres database. So now I've got it on a single platform, for instance. Then I can pull it into my data warehouse. So I'm processing it and pulling it into my data again. I can keep it all as a Postgres RDS or an Aurora Postgres or a MySQL if you wanted to. But I'm standardizing the platform and obfuscating that from the end user. From there, I can do my data marts. We've talked about data marts as far as using Redshift and EMR, but the point is I'm standardizing all of this now. I'm integrating it. I'm obfuscating all of this work from the end user, from the business intelligence community, from the data science community. On the other side of that, if I have unstructured data, right, I've got tools to do computer vision, so image recognition, natural language processing. That's textual analytics is kind of the field I play in. Automatic speech recognition. So there's textual analytics is interesting because there's a lot of things that you can do from textual analytics and marry that with structured data. You think about it in logistics. I am at a depot somewhere and I'm repairing some vehicle, and I've got some, I've paired this part with this part number, but I've also got maintenance notes on that, right? How do I take those maintenance notes and marry that with the structured data to glean some piece of information out of that? In healthcare, it's really common with doctors, right? Doctors have these systems, but if you've ever been in your doctor's office, they don't really sit there and point and click and fill out boxes. They just type in the notes field, and I've got to extract some information out of that. That's textual analytics, and the power is marrying those two things up. I can do all that in my data supply chain pipeline. So diving a little deeper into it, I can send to a FIPS compliant endpoint. I can use Lambda functions. So the neat thing about this design is there's always the, well, is my S3 bucket secure? And so the answer is going to be yes, we will absolutely secure S3 bucket, but I don't actually have to leave it in the S3 bucket that it dropped in, right? So if you take the security up a little bit further, I can have an ephemeral storage where I load my data in an external facing bucket where I'm dropping in an endpoint, and as soon as it hits that, I can pull it internally. So it's not accessible anywhere at that point, because now all I care about is processing it. I can use DynamoDB to capture all the metadata about it so I can track it. Data lineage, chain of custody is very important, because as you get downstream, if there ever are ambiguities in the data, you've got to be able to trace it all the way back to the source. It's very important. I can archive it on Glacier. One of the interesting things, if I archive it on Glacier, I could rebuild the entire thing from scratch if I ever needed to, because I'm keeping all of the raw data, which is pretty interesting. From there, I talked about the staging, right? If I've got a native or proprietary files, I need to stage those somehow. Why is it good to stage it in RDS? Because it's ephemeral. I can stand it up, load it up, pipe it down to my operational data store, and I can get rid of it. I don't have to do anything at the OS level. I don't have to maintain a database, and I can automate all of this stuff. Remember, once you develop some of the patterns and the processes, then you're able to automate it, and that's really what's important about all this. Then I start developing my data catalog. From your operational data store, from an MVP or an IOC perspective, that can provide you value. It's not the full smash, it's not the full Monty downstream, but I can get value now because now I've got all that data, I've got it in a format that people can access. It's not processed for quality or business rules. It may not necessarily be integrated from a business standpoint, but I can provide, now I've got data in one place that people can come and extract that data. And so as I'm building out the rest of my pipeline and developing that, I can provide value very quickly by going through this approach. So what are some of the next steps in this? Engage your AWS solutions architect. That's what we're here for, to help you develop this stuff. Develop a set of questions. One of the biggest mistakes I see in building these is we're just going to grab all this data, but we don't know what we're going to do with it, right? Start with a set of questions and work backwards. What are some questions we're going to answer? Where does that information exist? And then start pulling it forward and pulling more sets forward. And as you do that, you develop the capability and you develop the set of data gets larger and larger and larger. But don't start with we're going to just go grab all this data, because then you're just doing it with a bunch of data with no purpose to it. And so I think work backwards. Work backwards from the customer. In this case, the customer is going to be the commander or whoever it is making decisions. So start trying to develop those set of questions. Identify the information required to answer the questions. So again, the pipeline is going to be an ever-going process, this data curation. As I develop more questions, I get more answers. As I go out and look at these systems, oh, well, that's interesting. Maybe now I can answer this question about that I didn't know before. But again, it's got to be customer driven, otherwise there's no value in it. Identify the suppliers of the relative data, right? So if I'm going to use the Army logistics example. If I need to answer a question about force readiness and I have a logistics question, who owns all that data? And when I mean owns, who has the actual data? Not the middle kind of tier that somebody's built a warehouse to integrate some. So it's really important to go back to the source of the data, the original data. Most of the folks in the DoD that are in the room know there's a lot of tiers of that. And so you've got to kind of be careful about that to go back to the original suppliers of the data. What was the system of record? Build the solution platform. It's an ongoing process. Use the right tools, fit for purpose, fit for use. Start collecting and processing the data. It seems daunting. It's not as challenging, stepping through this and taking a methodical approach to it as it first appears. Because again, you're starting small. You're not trying to boil the ocean. I'm not trying to go out and grab 1,000 terabytes of data or a petabyte of data. I want to start answering questions immediately and identifying the information. Start answering the questions. So that is the end of my presentation. If anybody has any questions, I'll be sticking around here for a little while. Otherwise, I appreciate everybody coming, and thank you.